Hello, so today we are going to learn about roots. So, and next term is roots. So, we know that degree 2 equations are quadratic equations. And if we write this equation with the coefficients a, b, c equals to 0, it will become our standard form, right? And we need to find value of x. We need to find roots here. So, if I assume that factorization is valid here, so we can write the same equation in the factored form, that is a x minus alpha x minus beta equals to 0. This is your factored form, and here alpha and beta are your roots. What is roots? Roots are the value of x that makes the equation 0. Right? So, if you expand this factored form, you get x square minus alpha x minus beta x plus alpha beta equals to 0. Here we get ax square minus a alpha x minus a beta x plus a alpha beta equals to 0. We know that these are the same equation but in different form. One is factored and another is in standard form. If we compare these two forms, we get ax square equals to ax square. And if we compare this b coefficient, it will be minus a alpha and minus a beta. Cancelling this x, just comparing the coefficients, right? B will be minus a alpha and minus a beta, and C will be a alpha beta. So if we have, okay, so we are assuming that factorization is valid here. So we can say that this b terms breaks into two parts, and the multiplication of these two parts will be equals to alpha will be equals to a into c. What is a into c here? A is your x square coefficient and c is your a alpha beta. If you write a and c value a alpha beta, multiplying this a square alpha beta, and here also we get a square alpha beta. So from here we can say that factorization will be happen here, right? So from here we know that b will breaks into two parts, and the multiplication of those two parts will gives you a into c. This is the product term, right? If we take one equation, x square plus 5x plus 6 equals to 0. So, what do you know? You know that this is okay. So, first we have to compare with the standard form ax square plus bx plus c equals to 0. So, here you know that this b, the coefficient of x, will breaks into two parts, and the multiplication of those two parts will be equals to a into c. A into C here is A is your 1, B is your 5, and C is your 6 by comparing with the standard form, right? So, what is your A into C? A into C is your 6, and we call this A into C as your product term. So, how can you find those two numbers? That add up gives you the middle term, and product of those two numbers give you the A into C, the product term, 6. So, how can we find those two numbers? We need to factorize this product term, right? So so factorizing this product term, we get 3 into 6. 3 into 2 is 6. 3 into 1 is 6. So, 2, 3 and 1 are the factors of 6, right? So, by using these factors, the possible combination by using these factors, we need to form possible combinations that satisfying our condition of addition gives you 5 and multiplication of those two numbers give you 6. So try to make the combination. If we take 5 into 3, 6 plus 1 and multiply 6 into 1, we get 6. 6 into 1, 6 plus 1, we get 7. If we take 2 plus 3 into 1 is 3. 2 into 3 is 6. Addition of 2 into 2 plus 3 is your 5. So these are the two possible combination we can have by these factors. So which is satisfying our condition? This combination is satisfying our condition. So break the middle term using these two numbers. Breaking the middle term using these numbers. Now taking x common, and here we are taking 2 common. Okay, so we are trying to make these brackets common so that we can pull out a single common factor from here, right? X plus 3 is a factor and x plus 2 is also a factor. So from here, you can see that this whole equation is equals to 0. So either this is your 0 and this will be your 0, right? So taking these equals to 0, we get value of x minus 2 and value of x minus 3. So these are the value of x and these are roots of this equation. So if you put this value of x in your equation, x square plus 8x, okay, so x square plus 5x plus 6 equals to 0. If I put value minus 2 in the place of x plus 4 minus 10 plus 6, you get 0 here, right? So what we can say, what is roots? Roots are the value of the variable that makes the equation 0. So can you tell me the definition of roots now? Value of variables that makes the equation 0. So now can you solve this equation by the same method? So first step is to find the coefficients, right? Compare it with the standard form. A will be your 1, B will be 8 and C will be 15. So next step, you know that B will breaks into two parts and the add up of those two parts will be your middle term and the multiplication of those two parts will be your product term A into C. Multiplication of those two parts is your A into C, that is your product term, and A is your 1 and B is your 15. So the product term is 15. So to find those two numbers, we need to do the factorization. Okay, so find those two numbers. We need to factorize this product term. Product term factorization. 3 into 5, 15. 5 into 1 is 5. So 15, 3, 5 and 1 are the factors of this 15. So by using these factors, we need to form a possible combination that satisfy your condition of addition of numbers give you 8, the middle term, and multiplication those two numbers give you this product term, right? So let's try to make the possible combinations. If we multiply 5 into 3, 15 plus 1 and multiply 15 into 1, we get 16 and 15. So this is not satisfying our condition. If we multiply 3 into 1 and add 5, we get 8 and 3 into 5, we get 15. So yes, this is satisfying our condition. So if we split the middle term using these two numbers, 5x plus 3x plus 15 equals to 0. So now we have to take common here, taking x common. Okay, so taking x common here and plus 5, taking 3 common here, we get. So these brackets are identical so that we can pull out a single common factor, and the another factor here is x plus 3. And here you can see this whole equation is equals to 0. So either this will be equals to 0 or either this will be equals to 0. and we get x value is minus 3 and x value is minus 5. So, similarly, if we take another equation, 5x square plus 59x minus 12 equals to 0. So, if we take this equation, can you solve this equation by the same method? Okay, so here also you know that middle term will breaks into two parts and the multiplication of those two parts is your equals to product term a into c. That is 5 into minus 12, that is minus 60, right? So there is one thing. If you have the last term in negative, or you can say a is your 5, b is your 59, and c is your minus 12. So if you see your last term is in negative or your constant term is in negative, we have to subtract two numbers to reach the middle term, right? Earlier we have learned that we have to add two numbers to reach the middle term, right? But when you see negative term, constant term is negative and your last term is negative, so here you have to subtract two numbers to reach the middle term, right? So let's solve this. Here we have to follow same steps, right? First we have to find the coefficients. Second, factorize the product term. Factorize product term, that is 16. If we factorize 16, we get 2 into 30 is 60, 2 into 15 is 30, 3 into 5 is 15, 5 into 1 is 5. So this 60 has 2, 2, 5 and 3 and 1. These are the factors of 60, right? So by these factors, by using these factors, the possible combination that satisfying our condition of subtractions give you the middle term 59 and the multiplication gave you the product term 60. How can you form these combinations? Let's try to form. Okay, so if we take 2 into 2, 4 and 5 into 15 minus, okay, 15 minus 4 and multiply 5 into 15 into 4. We get 11 and here we get 60, right? If we take 5 into 10, 10 into 2, 20. If we take 20 minus 3 and 20 into 3, we get, here we get 70 and here we get 60, right? If we take 10, 20 into 3, 60, 60 minus 1 and 60 into 1, we get 59 and 60. So this possible combination is satisfying our condition that their subtraction give you the middle term and their multiplication give you the product term. So from here, if you split the middle term using those numbers, we can write it as plus 5x square plus 60, okay, sorry, 60x minus x minus 12 equals to 0. So taking x common here, 5x common here, we get x plus 1 into 12 minus taking 1 common here, x minus minus plus 12 equals to 0. So here we have two factors, x plus 12 and 5x minus 1. So either this will be equals to 0 or either this will be equals to 0. We get the value x minus 12 and x is equals to 1 by 5. These are the roots. If we put this value in our equation, it will give you 0 value and that's why we called it roots, right? So this is how we can solve the equation by the factorization method. And if I take another example, 3x square plus 10x plus 2 equals to 0, can you solve this equation by the same factorization method? First step is to write the coefficient. I am writing a is 3, b is 10 and c is your 2. So b will be break into two parts, right? And the multiplication of those two parts will be your a into c, the product, that is 6 here, right? So if you factorize this 6, we get, okay, so 2 and 3 and 1. These are the factors of 6, right? So, by using these factors, can we form 10? Okay, so let's take, if I look at the factors of 6, none of them give us 10, right? We can form a possible combination. We cannot form a possible combination that's satisfying our condition, right? 6 plus 1 is not equals to 7, is not equals to 10, right? So there is none of the possible combination, right? So factorization fails here. Factorization is fails here. But it doesn't mean that this equation has no roots. We can find the roots of this equation by one direct method, and that method is quadratic formula. Okay. So, and this method never fails. If your equation is in fraction or in decimal, you can still find, okay, if your whether your equation is in decimal or fraction, this method will still find the roots, right? What is this quadratic formula? It's just a standard equation solving for x. This is your standard equation. If we solve this for x, let's say, okay, so we are dividing from a, dividing by a, we get x square plus a by b by a, x plus c by a equals to 0. So now, okay, so do you know what's the meaning of x plus r whole square? How can you write this? You can write x plus r square whole square as x plus r times x plus r. So there is one distributive property which says if, if this is distributive property, right? Here the outer term, you have to multiply multiplication among the bracket with the outer term, right? If you multiply a, it gives you ab plus ac, right? This is your distributive property. If you apply the distributive property here, you get a x square plus xr plus xr plus r square. Here we have x square plus 2xr plus r square. So what we can do here is, if we take this x square corresponds to x square, right? Plus we need to have, if we take x square corresponds to x square, plus we need to have 2xr here. How can we have 2xr here? Okay, so you can see there is b upon a, and we, how can we make the middle term b upon a? How can we make this middle term b upon a keeping what 2 and x? How can you make, if by taking b upon 2a, if you take b upon 2a, you get 2 will be cancelled out, you get 2x upon a, right? So if you multiply 2x with b upon 2a, you get b upon ax, right? And from here you get the value of r, that is b upon 2a whole square. And originally we have from the equation c upon a. So what additional thing we have done here is we have add this term. So it disturbs the balance of our equation, right? So we have to subtract the same term to balance this equation. Okay. So we can write this as x plus b upon 2a whole square, right? And taking these on the right hand side, b square upon 2a whole square minus c upon a, right? So now, okay, so let's say you have under root 4. Okay, so if you have minus 2 whole square, what will be the answer? 4, right? And if you have 2 whole square, what will be the answer? 4, right? So there are two values that fitting this under root, right? So whether, so whenever there is under root, it will gives you two values, positive as well as negative, right? So if you remove this whole square, it will give you under root, right? So here you know that there is two values that fitting this under root, right? So there will be two values, plus as well as minus. If we take this term on the right hand side, we get, and this is your quadratic formula. This is your quadratic formula. Now, okay, so don't look at the whole formula. Just look at this box. This is your discriminant. Discriminant. It tells us the nature of roots before solving the whole equation, right? Nature of roots. D is your b square minus 4ac. If d is greater than 0, you got two real and distinct roots. And if your d is less than 0, you got two imaginary and distinct roots. If your d is equals to 0, you got one real and equal root. And if your d is a perfect square, so you will get rational roots. Roots will be rational. Okay, so what do you understand by rational? Rational are the number that can be expressed in p upon q term. Can be expressed as p upon q. And here q cannot be equals to 0, and your p and q are whole numbers. So you know what is whole numbers, right? So it can be like 2 upon 5, 5 upon 6, but it cannot be 2 upon 0, right? Why it cannot be 2 upon 0? Because we know we cannot divide anything by 0, right? So this is not possible. Now, okay, so can you solve this equation by the quadratic formula? 2x square plus 7x equals to minus 4. So, if there are number on the right hand side, the quadratic formula wouldn't work. Everything must be on the left hand side and equals to 0. Okay. So first step is to compare the coefficients, and we get A is 2, B is 7, and C is 4. So first we need to find, okay, so first we have to find the discriminant. Discriminant tells you the nature of roots. B square minus 4ac. Is your 7, A is 2, C is 4. Here you get 17. And here D is your greater than 0, so roots will be real and distinct. If you put this D in your quadratic formula, minus B plus under root D upon 4A and x minus b minus under root d upon 2a. This is your another root. If you put the values, b is 7 plus under root 17, 4, 8. This is your minus 7 minus under root 17 upon 8. So these are your two roots. Here you can see under root 17. Okay, so you can leave this solution here also, and if you want to write the value of under root, so this under root is a rational number, right? You know that. So this under root 17 doesn't have any whole number square root. What do you understand by whole number square root? Like under root 16 has 4. Under root 25 has 5. These are the perfect square, right? So since 17 is very close to 16, right? So under root 17 must be a little bit more than 4, right? So We can write under root 17 is like approx 4.12. And if you want the exact value of root 17, so we have one formula. This formula is not very necessary to learn. This formula is a plus x minus a square upon 2a. Here x is your 17 and a square is your nearest perfect square, that is your 16. And if a square is 16, a will be 4, right? If you put these values here, you get x is 17 minus 16 upon 8. So from here you get 0.12. So this is under root 17 is your 4.12. This is the value of your under root 17. So is there any doubt till here? So, okay, so if we are asked to find the sum of roots and the product of roots, do we really need to solve the whole formula? We know that one root is your minus b plus under root d upon 2a, and another root is minus b minus under root d upon 2a. Okay, so these are your roots. If you were asked to find sum of roots, let's say one root is your alpha and another root is your beta. I am taking alpha beta, you can take any other terms as well. Okay, so if you add, sum of two roots will be b upon 2a distributing among the bracket, among the denominators, minus b upon 2a minus under root d upon 2a. So here you can see this term and this term will be cancelled out, right? So we can write as minus 2b upon 2a. Here we get minus b upon a. And if you multiply these two roots, we get there is one identity. Okay. So do you know how can you write a minus b, a plus b? This can be write as a square minus b square. Okay, so we have learned the distributive property. Can you expand this? This will be a square plus ab minus ba minus b square. This will be cancelled out, right? And this will a square minus b square. So here, if you take a as minus b and b as under root d. Here also, if you take a is minus b and d as under root d, so a plus b, a minus b will be your a square minus b square, right? And here we multiply, it gives 4a square. So minus b whole square will be b square and under root d square will be d 4 square. We know the value of d, it's b square minus 4ac. 4a square, we get minus minus give you plus ac upon 4a square. B square will cancel out and we get c upon a. These are the product of roots. Product of roots will be c upon a and the sum of roots will be p upon a, right? So this is all about quadratic equations.